You will have examples in your homework when you do integration by parts twice. That sometimes you have a recursion. Do you know what recursion is? Thing happen inside of the thing, inside of the thing, inside of the thing. It's like mirror in front of the mirror. We have recursive integration by parts. I have video about it. It's pretty fun. So I'll post the video. It will help you with your homework. But this one is not recursive integral because let's choose something to be u. Liate says, let's see. Liate says, I don't see any log. I don't see any arcsine or cosine. I see algebra. Algebra is 3x. Exponential function should be your last choice to be u. So let's choose 3x, which we actually could kick out 3 outside and do not use 3x, but it's fine. Let's choose this to be u, then everything else does not have a choice. It's going to be dv. And the integration by parts process starts. U is 3x. du is 3 dx. Let me stop, not to be too fast. dv is e to the 5x dx. And this is the most important part of this example. What is my v? V is the integral of e to the 5x. I remember that when you integrate or differentiate exponential function, it just copies itself. And that's what most of the students do. And lose points because there's a 5 over there. Do you want to do chain rule? This is a shortcut. You divide by the leading coefficient of this function at the exponent, which is 5. So don't forget to divide by 5. Does that make sense? Do you remember this? We had a class about this shortcut of u substitution. It is actually u sub. Let me make a link here. This is a u sub shortcut. I also have a very good video about that. Shortcut. We did u substitution by choosing 5x to be u, blah, 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 and then divided by 5 at the end. But it's just faster to remember it. Okay, cross product minus bottom product. This is how people remember it. U times v minus v du, or integral of v du. 3x times e to the 5x over 5. This part is done. Minus integral, multiply everything at the bottom. So e to the 5x over 5 shows up twice in this formula. V shows up twice. Times 3dx. 3dx equals. So I will stop for a second. What do you think about that? We hope to get a part that is ready, which is the first part, and the simple integral. So I'm looking at the second integral and I'm like, yeah, I can do that one. If you cannot, then it's a struggle. You have to figure out what to do again, maybe one more integration by parts or not. But in this one, seems like it's okay. So we have 3 over 5 x e to the 5x. That's the very nice way to rewrite the first part. Constants together, x together, e together. Minus 3 over 5 integral e to the 5x dx. But we just did this integral, so we know how to do it. The answer will be 3 over 5x to the e to the 5x minus. Who's playing with the phone? You guys. Come on. You can watch your TikTok later. What is integral of e to the 5x again?
E to the 5x over 5.
Over 5. All agree? Plus c. And this is the answer.
Wait, where did the 3 go?
3 disappeared because it's needed today, you see? 3 over 5. I think it's pushing me to upgrade to Windows 11, and that's why it's slowing it down.
Oh, it's 3 moved. Okay, so 3 moved there.
Yeah, it's there. Not too bad. What do you think?
Shouldn't it be 323?
It should not be 3 over
5 times 5. Yeah, the whole fraction disappeared. You're right. 3 over 5 times 5. So let's just do 25 right away. 325. 5 times 5 in the denominator, right? Not too bad. So this is good. Ask me, what do you think? Can you do it on a test? It's kind of exactly very classical examples. We always do on a test, to be honest. Yes?
Why?
Yeah, ask anything.
So we have denominator 25, so we have multiplied by 3/5.
So it was, 3/5 times 1/5 one more time.
Oh,
So I kind of skipped the step and collected this into 5 times 5. Yeah, exactly. It's 3/25 if you wanted to do this one. Even better. Now, let's do something with sine and cosine and definite integral. I'm surprised they don't really give you definite integral that much, but let's do one. Example 4. So how do we deal with definite integrals? Remember last class I was holding bottles and I showed you that when we do U substitution last week, I'm moving water from one shape to another shape, and that's why U substitution is a transformation. So when I'm working with definite integral, for example, from 0 to pi, to pi over 5. Yeah, that's good. From 0 to pi over 5. When I'm working with a definite integral, 2x cosine of 5x dx, with U substitution, we were changing limits of integration because we were transforming one function into another function. Area below unusual shape into the area below shape we know, like a measuring cup. So we were changing integration, limits of integration. For integration by parts, you don't do it, and that's the good news. Integration by parts is not a transformation. Let me write down this note. Note. For definite integral, definite integral, so they want to have defined limits of integration. Integrals, integration by parts doesn't change a and b, limits of integration. No need to change a and b. In U substitution we did, because U substitution was a transformation, while integration by part is not a transformation. Integration by part is calling names. I'm calling this piece to be U and this piece to be dv, so I'm not changing one integral into another. I'm just renaming them. That is a difference. Very interesting idea here. So let's do it. After this note, it actually makes it easier because it means 0 in pi over 5 will stay 0 in pi over 5. Let's choose something to be U. Help me to choose U. What do you think U should be? Li at tells you what? Li at, log inverse.
It should be cosine phi of x, right?
Let's see. Li at tells you log, I don't see log. Inverse, I don't see inverse. A, algebra, 2x.
Sorry.
And then trig. So if there's no algebra, but for example, exponential function, you will use cosine to be U. And this is how you choose U to be cosine and it doesn't work, you get frustrated. So it's pretty cool to have li at. Li at helps you to avoid this extra waste of time. If U is 2x, you immediately differentiate it. Du will be 2 dx. Everything else doesn't have a choice, it will be dv. dv is this whole tail. dv is cosine 5x dx. Help me to integrate cosine 5x. That is going to be a challenge. Let's see if you can do it. I will wait for you to think about it. How would you integrate cosine of 5x? What is the first step at least? Anyone wants to try? Integral of cosine. Anyone? Yeah? Sine. Integral of cosine is sine. That is good because I remember derivative of sine is plus cosine, so no need to have negative. And then what about 5x? Over 5. I'm doing chain rule, thank you. I'm doing chain rule. Don't forget when you're stressed during the exam. I kind of think most students remember to do it, but not on the test when you're stressed. And this is the American system of testing. 15 minutes, too fast, you run, and you forget those small things like dividing by 5. Yes?
Why would it be divided by 5?
So when you differentiate, you multiply. When you integrate, divide. When you differentiate, you do chain rule. When you integrate, you undo chain rule. Yeah. I don't know, it's hard to remember. So try not to forget this on the test, all of you. So that's the thing, students are smart and usually they work very hard before the test. Then the anxiety hits, timer is on the wall, and you just forget those small things. That's why our exams are 3 hours long, and in Ukraine, have 3 hours, you will not forget those little things. Here's just too fast. Cross product 2x sine 5x over 5 minus bottom product, but instead of the integral, sine 5x over 5, this thing happens twice, so you can just copy it one more time, times du is 2dx. This is what we did before in 3 examples already. So what's so different in this example, except cosine, of course, and sine? This integral used to be definite integral, so what happened with 0 and pi over 5? And this is pretty cool. We never had to change it. What is going to happen is, left-hand side of the result is the integral which is already done. So I'm putting a bar, because there's no integral sign. Instead of plus c, I'm putting a bar. 0 pi over 5. That part should be still calculated for the particular numbers, 0 and pi over 5.
Is there a reason you put it in the middle?
What?
Is there a reason you put it in the middle?
So listen carefully. Minus integral. This is still an integral. These integrals have to be integrated from 0 to pi over 5. So the idea is still the same as before. Integration by parts gives you results with 2 pieces. One piece is already integrated, and the other piece is still an integral which have to be integrated. But since it's a definite integral, the first piece have to calculate it at the point 0 and at the point pi over 5 to give you a number. Now this is supposed to be a number, not a function 2x sine 5x over 5. And the second part have to be integrated and also plug the points. So interesting that the second part is one step behind in the first part. And then students choose how to do it differently. Some students wait for the second part to be done and plug everything, 0 everywhere and pi over 5 everywhere. Or you can plug in right now, 0 and pi over 5 at the first part, 0 minus, so 0 gives you 0 right away, and then you calculate, so I will do like so. The first part. I'll put it in brackets for you to have it very visual, like so. Bigger brackets. 0 gives you 0, we plug the top first. 2 times pi over 5 sine 5 times pi over 5 over 5 closed. That's plugging the top. Mine is plugging the bottom, but 0 makes everything 0 right away. And this is the first part. The first part only. The second part, I cannot plug numbers yet because it's not integrated. So let's integrate it. So the second part is one step behind. Again, what is the integral of sine 5x multiplied by 2/5? It's going to be some kind of cosine, right? So I'll write down cosine and then decide on the sine. Cosine 5x over 5, we know that. And we also know there's a 2/5 hanging out inside of the integral. But derivative of cosine is minus sine. So actually it should be minus. Make sense? Agree? Now look at this mess. You're not supposed to leave it like this. So I will put a huge bracket. Put a bar. And now this is from 0 to pi over 5, just like the first piece used to be. So now the second part caught up with the first part, and you could plug in the numbers here. But again, some students actually do not plug the first part, they integrate the second one and then plug everywhere, 0 and everywhere pi over 5. Yes? Yeah. I was curious if you guys gonna ask about this. So I see this integral in my mind like so. It's the integral of 2/5. I will kick out the constant. Always kick out constants. It's too much work to see them inside. Sine 5x dx. This is how I see it. From 0 to pi over 5. Integral of sine is minus cosine. I don't remember that. I remember that it's either minus or plus, and then I'm differentiating cosine in my mind. Since the derivative of cosine is minus, then I should put minus cosine. So integral of sine is minus cosine 5 over x, but also divided by 5 to undo chain rule. And then multiplied by 2/5 because they were there at the first place. And this negative sign. Does it make sense? Ask me. Not too bad. Finally, we're plugging numbers into the second part. Tell me what the result of the first part. Does anyone know? I would just simplify the first right away to know what's there. Since you have sine 5 multiplied by pi over 5, that is actually sine of pi. What is sine of pi? Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0 again. Because sine is your height on the circle. At 0, height is 0, and at pi is 0. So it's all 0 actually. 0 minus 0. Minus, and now I'm plugging top minus the bottom in this math. Let me simplify. It's going to be 2 over 25, just like we had in the previous example. Minus 2 over 25. And now we're plugging cosine 5 multiplied by pi over 5 minus, but it's still minus over there, so be careful, and probably open parentheses and put minus in front of the cosine because it was there. Cosine of 0. That is not 0, so you have to write it down. I did not factor out, so we have to do 2 over 25 one more time. Or you can factor it out. And then you close brackets. Be careful with parentheses, so let's see what I did. I'm actually pretty good at being good with parentheses. These parentheses are inside of the cosine. Brackets are outside. And then these parentheses are needed because cosine is negative. So minus gives you plus, and I don't want to lose that. What is cosine of 0? Pi is negative 1. So cosine of 0 is positive 1. And cosine of pi, 5 cancels with 1/5, is negative 1. So we just need to carefully collect. So is it negative, positive, or negative and stuff? We definitely have 0. Let me put negative in front and open these brackets and see what is inside. This negative is part of the formula for the integration by parts. So this is in front in the first place. Let's see. Minus 2 over 25 times minus 1 is plus 2 over 25. Nice. Minus gives you also plus. So they will not cancel out. 2 over 25. 2 over 25. So the final answer is minus 4 over 25. Agree? Or maybe you have something different.
But an area cannot be negative.
Oh, it's not. First of all, area can be negative. It's below x-axis. And second, if this, it just means something below is more than something above, if you remember that. But if we're talking about volumes and stuff, yes, then you have to be careful with that. So, what I wanted to show you, ask me about the procedure, because procedure is long but pretty interesting. But I wanted to tell you that to help you with homework, I should tell you, sometimes not all professors like telling it to students, but I think it's nice to tell you that Wolfram Alpha can do it for you. So to be honest, you can check your answers using Wolfram Alpha, just don't rely on it too much to make sure you can also understand it and do it in class and yourself and on the exam. So for you to know, if I do integrate 2x cosine of 5x, right? That was the original thing. From 0, I just randomly chose, well, not very randomly, but I chose from 0 to pi over 5. Click enter. Oh, that is, yeah. Minus 4 over 25, like you asked about negative area. It means negative is more negative than the positive one, so the total is negative. Let me make a screenshot of that. But the cool part is that Wolfram Alpha does integration by parts. Here, it knows this rule. And it gives you the solution. Here it is. This is indefinite integral solution right before we plug the numbers. This is what it is. Right before we plug the numbers. And then, if you want to know how did it integrate it, you click step-by-step solution, and it shows you integration by parts. It shows you the formula. You recognize it. Instead of UDV, sometimes people call it FDG. It starts integration by parts, and then it tells you if you want to see more steps, become pro. For you to know, ASU has free access to the pro account. You go to my ASU, click apps, and you find it there. So it's actually free for instructors and students. So you can check these step-by-step solutions as well, because it shows you choosing U to be X, DU to be cosine 5X, and so on. So that will help you with your homework. Just again, don't rely on that too much. Make sure you understand what is happening. And also remember that Wolfram Alpha has its own notation for everything, but it does use substitution. What do you think about this? Not too bad? Then I think it's good for today, and you guys, thank you for coming.